Imagine your next Netflix binge or AI search being powered by servers 250 miles above your head.
Is it the ultimate power move or a kind of weird, stupid, costly pipe dream? We're diving into the race to build data centers in space.
Data centers in space. It sounds cool. It is cool. It's going to be a wild, mind-blowing episode, Nick.
It sure is. Out of this world, in fact.
Yes, we're going to review over some of the basics of a data center, what they are on land, what they are in space, how they work, and then we'll review over the benefits, the challenges, and some of the impacts of having one. And then we'll review over the companies that are pursuing it and then provide some timelines. We're going to keep things basic. So if you are not a technical listener, we will be able to inform you on how they work at a high level. And if you are a technical user, guess what? We're going to provide some very good insights into technology that you probably don't know.
I was excited to do this one because I keep hearing the headlines, right? But to me, it's like, this sounds so stupid. Someone make this make sense for me. Like, how is this cheaper, right? How is this possibly cheaper? But it's surprising to look at some of the numbers. We'll get into some of that.
Indeed. So does it make sense? What are the numbers? All questions we're going to answer today. Let's get into it. Let's start at a high level with basically what is a data center. And so at a very basic level, a data center is a specialized facility that houses powerful computer systems, storage units, telecommunication equipment, and it acts as basically a digital warehouse for storing, processing, and distributing data.
So for years, data centers were mostly storage, right? Storing all your files, all your Dropbox files and everything, lots of hard drives. In the age of AI, so much of that infrastructure has moved over to powering AI, to GPUs, right? It's been a huge boom. We're still calling them data centers, but they're actually quite different than they were a few years ago, at least a vast majority of them. And there's a lot of money going into this, a lot. Scaling, we've been in the age of AI scaling for the past few years, and for a while, the people that win are those that have the biggest, most powerful data centers, right? And so this is why we're seeing so many headlines, so many new companies come up to build these data centers.
It's been a huge boom. I believe they're called the hyperscalers. There's the race to build data centers and the amount of money and funding going into it. Because you're right, it's not just storage anymore. It is processing. And because these AI models require a lot of compute to run, they require a lot more processing. So there's a storage aspect, there's a processing aspect, and there is an updating aspect where they are continuously connected to the internet and allowing them to receive and process real-time information. They scrape everything out there on the internet. They update their models. They listen to our podcasts. Of course, they learn from us.
Yes. Yeah. This is how they're getting smarter and smarter. They're studying this podcast. My God,
And then,
these two are brilliant.
Then for, let's say, users on a device. So when you are on your cell phone and you want an answer to a question, perhaps you're going to ask, what do robots look like naked? Okay. That question is going to go from your device, right, through your internet service provider via ground cables or wireless link to a data center that processes the request and then goes back the reverse path to your device. That's how it works.
You no longer have to draw out naked robots yourself. You can ask AI what it would look like, which saves me a ton of time.
I've never asked AI that. I wonder how it would react.
Is that what you said? I just imagined that.
I said, what do robots look like naked? Assuming
Okay.
people search that, but maybe that's just us. And then so, but that workflow of how it currently works on land is a little bit different of a potential workflow is if the data center is in space. So
the workflow, you mean like the data flow? How is it any different? Really?
The data flow would be different, right? Because these data centers in space, they don't have walls, they don't have floors, and they don't have cooling fans, right? A data center in space, what they actually look like is basically a cluster of satellites in low Earth orbit. And they're equipped with a lot of high performance computing hardware, like whether it be Google's TPUs or other advanced GPUs like from NVIDIA. So they're essentially satellites working in clusters with a lot of high performance computing. So the workflow gets a little bit different. And these groups of satellites are basically connected to each other Some of them it looks like they're going to be connected with laser connectivity, which
Which
is
sounds like silly and futuristic, but that's literally like the best way to communicate in space, or at least currently the highest bandwidth way to communicate versus radio. And since you're in space, you can actually use lasers because you're not shooting it through the atmosphere. Yeah, it's pretty cool stuff.
data centers in space are using laser link connectivity. Whoa,
Whoa, whoa.
advanced.
Dr. Evil would love this.
This is a Dr. Evil. This is a James Bond villain
It's
plot
totally a
right
James
here.
Bond thing, right? Yeah.
Absolutely. So, I mean, how they are differ and some of the challenges that come with it is going to be the power source, right? Data centers currently are, drawing power from local grids. They require a big backups for fuel backups. They require a lot of solar energy, perhaps, and then cooling too. The data centers on land have massive cooling requirements because data centers get very hot. So they have massive HVAC systems on land. They use a liquid cooling that requires a lot of water, actually. The statistics, when you see how much water data centers require, is actually quite astonishing. Like you could drain a lake to basically power a data center. So they're not the most sustainable at the moment. And then there's scalability challenges, right? Because they are limited by lands and permits and power grid capacity. So all that stuff's a little more limited. But in space, Nick, the limits are very different.
Lots of real estate up there.
Lots of real estate
Lots of
and
room to stretch your arms.
lots of solar power. So
Lots.
potentially a data center in space would have 24/7 solar energy powered. So that they wouldn't have to have backup power or so on like we would on Earth. There wouldn't be the same interruptions. There would be a constant sustainable energy source for the data centers.
This data, all of these points, all of these advantages, every single one of them, there's tons of potential skepticism around these. Like I'm skeptical of a lot of these, right? So each one of these, right? Energy, well, that's so stupid. Why don't you just use solar cells on Earth, right? Yeah, at night you're not getting sun, you're not getting power, right? You can in space go up into what's called a sun synchronous orbit where instead of going around the earth like this, you're navigating the earth like this so that you're always looking at the sun. And yeah, that can be an advantage. And energy usage is a huge cost for these data centers. People don't realize it's not like just plug it in the wall and there's free energy. People are so used to thinking like electricity is basically free. It's not. Over years' time, they spend a lot. And in fact, that may be the real currency that we're dealing with here. In a way, we're turning energy into intelligence, right? And
Yes.
and it's extremely costly. The cost of chips is dropping like crazy. The cost of energy is not. In fact, it could go up with demand going up, right? And so, okay, it's that part, it starts to make a little more sense. Maybe it does make sense to have these to just be going off solar in space. And of course, solar is more efficient in space. It doesn't have to travel through the atmosphere, right? So you can get a little bit higher power output.
Exactly. So that's some of the benefits to having a data center in space. You have unlimited solar power in a vacuum so cold it could chill 1 million servers. So both of those are problems with land-based servers that space-based servers would address. And then also much more sustainable. Like you said, the energy cost for a space-based data center is 10x lower than the cost of a land-based data center.
The cooling issue, that's another point of skepticism. You're going to hate this. I'm going to keep bringing up all these skeptical things. So in space, yeah, it's cold, but there's no atmosphere to suck the heat away. It's not like here. Yeah, it's cold, kind of. You have to radiate all the heat away. And it requires very different cooling than on Earth. That's not to say that it's not possible, but we're going to be having to ship huge radiators, a lot of extra metal up to space for these to be able to cool. Different configurations of the actual chip and cooling and heat sinks. But I don't know. It sounds like they have a plan to figure this out.
The cooling is still an engineering challenge.
Yeah.
Because you're right. When you're in space, there isn't air to conduct cooling like there is on Earth. So this is a little bit of thermodynamics. I'll have to
Mhm.
tap back into my knowledge from when I took this in college. But essentially, you can conduct heat through conduction, which is a physical element conducting heat to another physical element, like when you touch metal and it's hot. Then there is convection, which I believe uses gas and liquids, I believe, to transmit heat. And then there is radiation. And then I believe the strategy right now for cooling is potentially use it the radiation power, the irradiated hearted. So that would be the potential for cooling. It's a little more complicated. However, it has the potential to be efficient. It does require a little bit more durable hardware than using land-based data systems because of
You
the
mean for the
cooling.
cooling, or you're talking about hardened for radiation, in
The
space?
cooling, so they would have large satellite, and then there would be some kind of liquid cooling going through the device, but it would be able to maintain the liquid temperature to cool the devices, where on Earth, the water would need to be constantly chilled, is my understanding. Is that correct?
Yeah. Yeah.
And then all the chips and hardware would also need to be a little bit more engineered to survive in space, which is a different environment. Challenges there too.
And don't mess it up, because
And
there's
don't
no
mess it
fixing
up.
it. It's no fixing it once it's out there.
The maintenance issues and replacing things that are broken in space could be very challenging as well. Let's talk about the costs though, because there are a lot of challenges with the costs, specifically the launch costs and their costs. Nick, you did some research on this. How do we compare the cost of a land-based data center to a space-based data center?
Yeah, first, over the past few weeks, few months, I keep seeing these headlines on space-based data centers. It's like, this makes no sense. How does this make sense? How, right? And then, and there's so many people that have their opinions on it. You watch some podcast, couple of dudes that know nothing talking about this. There's no good info there, right? Finally, I found a table that showed the cost breakdown, and it makes it super clear, right? Um, the energy cost, like we were saying, it really adds up over time, right? This is something I believe from StarCloud, it's a Y Combinator company that's doing. They're estimating over 10 years' time that the energy costs for a specific AI data center would be $140 million, right? So compare $140 million. Nothing you can do. You got to pay for that energy when you're on Earth. This is for a terrestrial data center, right? Compare that to space, where the energy costs are zero, kind of. Obviously, you have to build out the solar cells, right? But compare that to the launch costs, which shockingly, they're getting shockingly cheap now. SpaceX has driven down the costs of launching. I remember when we were kids, right? It was like, you want to send a kilogram to space, it's going to cost you $50,000, right? It's like $1,000 now and dropping, right? So StarCloud is saying, I think they're estimating a launch cost of $5 million. So in a way, it's comparing $140 million to $5 million. That's where it started to make sense for me, right?
Yeah. Okay. So if it costs 140 million for a data center if the
Just
energy
the
cost for
energy.
a data center on land costs 140 million dollars over 10 years, then the costs of a data center in space, the costs are mainly going to be with the launch, which is kind of more of a one-time cost,
Yep.
and then some ongoing maintenance costs, which we probably don't have a good way of estimating yet,
No.
and then maybe some costs with the equipment and the shielding and the R&D, of course. But you could see a business case making sense if it costs 140 million in just energy, and you have the potential to dramatically reduce that and save 100 million dollars. Then all of a sudden, the numbers make a lot of sense for a data center in space.
Yeah. It has to absolutely make a ton of sense, like a couple orders of magnitude better for this to have a chance to really work, in my opinion, right? And it looks like they have that, right? There are obviously going to be challenges. Everyone knows there are going to be challenges, but you need to know what success looks like, right? And if it can be 100 times cheaper over 10 years time, yeah, there's a chance this could work really well. And what's cool is that if this works at all, it's extremely scalable, right? You're not going to run out of space.
It
I mean,
is.
you could argue that you there's space junk and everything, but there's a lot of room up there.
There is. And I've got a couple mind-blowing future use cases of what we would be able to do with space-based data centers. Are you ready to get your
Cool.
mind blown, Nick?
I'm ready.
Okay, so picture a future where we do have data centers in space that are able to collect real-time surveillance of Earth. Like real-time surveillance. Right now, we don't quite have real-time. We have satellite imagery, but we have real-time satellite surveillance, collect all of that data, and then analyze. We would be able to have real-time, instantaneous global disaster detection. Let me say that again.
Interesting.
If we had data centers in space, we could have real-time global disaster detection.
Like forest fires, maybe?
Yes, forest fires, which we know have ravaged through California, hurricanes, like you name it, there could be real-time surveillance and information and data that we get back. And then here's even a more mind-blowing thing. If we had data centers in space that would collect real-time data of the Earth, we could create a digital twin of Earth and simulate it across a lot of different environments and scenarios, and essentially run simulations on perhaps weather or other environmental concerns to create potential solutions for big concerns like global warming.
Interesting. Weather. Yeah, maybe that could be solved. Maybe that's a data problem. It's just getting better real-time data for weather prediction.
It's not very good right now. Check a
It's
10-day
not.
forecast.
Yeah, and it's always wrong.
It's always wrong. It's always wrong. So not only now we were collecting real-time data, satellite imagery data, we could do a lot more instantaneous detection. And then here's another really crazy one. Are you ready, Nick?
I'm ready.
Are you ready?
I think so.
This one, you got to put your maybe tinfoil hat on a little bit. But if we have data centers in space who are able to collect information from satellite imagery and communicate and transmit the data, it could have potential use for interstellar communication. Would that be communication with other humans, maybe that are in deep space missions, or perhaps they're humanoids or robots that might be there, like a Mars rover,
Maybe.
for instance, or
Yes.
maybe they're non-human.
Wow.
Data centers in space can talk to aliens. And we know aliens are real. In 2025, go watch The Age of Disclosure, a great documentary out there. We know that there's things out there that are not from this Earth, that there's technology more advanced. And as we build out these data centers in space, we're going to have a lot more surveillance, not just on Earth, but of greater space and potentially come in contact with
You know
extraterrestrials.
what? Actually, back to your point of if we really did build this out and cover the Earth and had constant real time visibility of everything on the Earth, we'd see a lot more of these UFOs. I mean, they're sparse out there, and like this sounds kooky, right? And it makes me cringe to even say UFOs, or what do they call them now? UAPs or something? I don't know. Yeah, people keep seeing them. And it's just that we don't see them as often because the Earth is kind of big. And man, that would be cool to have a constant view of the entire Earth and to see what the heck is going on with these things.
Yes. And into space. So we could do a whole podcast on UAPs, but data centers in space do expand our capabilities quite a bit. And the use cases for it are kind of unimaginable at the moment. Like we don't even know what are the benefits we would get from a data centers in space and the ability to collect data from space. We'd learn a lot from this. It's pretty
could be
crazy.
The beginning of building a Dyson sphere. You know what a Dyson sphere is?
No.
Dyson sphere it's a sphere or a cloud of satellites with a purpose of basically covering the entire sun with solar cells. So they say in science fiction, they talk about the stage of civilization that you're at. There's stage 1, which is using all of the solar energy that hits your planet. Stage 2 is using all of the solar energy that comes out of your nearby sun. Stage 3 is using all of the energy of your current galaxy. And we're not quite at stage 1 yet, right? We're at like 0.7. It's a logarithmic scale. And when you think about those stages, you realize how much, we are just in our infancy here. And people could say, well, why would you need that much energy? Like, we're finding ways to need a lot of energy. So if we start building data centers in space, building all the infrastructure for the solar cells to power these, this could be the beginning of now kind of reaching out toward the sun and putting solar cells orbiting the sun and capturing a lot more energy. This is the kind of stuff that's like every geek wants this to happen, but we obviously need a commercial way, a sustainable, profitable way to get there. And so it's kind of fun to think about that this could be the beginning of that. Like,
That is crazy. Tapping into the energy outside of Earth to power Earth or our advances in science
yeah,
and technology.
yeah. All to power us asking AI to generate images of us. Yeah.
Or robots.
Worth it.
Yeah.
Or robots.
What do robots look like naked? I need the most powerful processing in the universe to give me the right, correct image.
Mm.
So, to your point, it needs to have commercial use, and there are companies that are pursuing it. So, let's go over some of the companies who are pursuing data centers in space. I'm going to share my screen,
Cool.
and I'm going to talk about StarCloud first. So, StarCloud is a startup, um, and they are a Y Combinator startup. And this is the imagery they have of their potential future data center in space. You can
So
see this,
cool. Star Cloud. So it's YC. This is formerly Lumen Orbit, right?
I believe so.
Yeah. Okay.
And this would be what a data center in space looks like. You could see a huge panels of solar with basically this kind of that satellite connection in the middle. And then I believe they would have a cluster of these that would be communicating with each other too. They did publish a white paper, and the white paper you can find on StarCloud's website of why we should basically train AI in space. They do go into more detail. I think it's about 15 pages or so. It's pretty interesting stuff we're getting into. So they have basically started to launch prototypes into space of what these potential data centers would look like. I believe they partner with SpaceX for the launch, and they have some prototypes in action today. They're not the only ones pursuing this, though. There's quite a few other people in this race. So Google also plans to enter the race, and they have a project called Project Suncatcher for their data centers in space, where they're also going to have a large solar panels powering probably their chips and computing for a space data center. And then the other big player in the space, which has gotten some notable attention, is SpaceX. SpaceX, who already has a pretty big lead with Starlink being the internet connectivity satellites that are out there, already has the ability to launch. And not only that, they are potentially, entertaining the ability. They are potentially entertaining an IPO with part of this
And
being.
Elon has XAI. He needs a lot of data centers.
It is kind of crazy how his vision with all these different companies they've started could potentially come together. So
Yes.
with SpaceX entering into this race for space data centers, picture this, Nick. SpaceX has a space data center integrated with their Starlink connectivity offering. So now you could have data basically stored and processed in space in a data center, transmitted to Starlink, right? And then that could be communicated either to Earth or to space, could be transmitted. So you could go directly to someone's device on Earth in any remote location or remote locations throughout space.
That is one of the big challenges for space data centers is communicating back to Earth, and SpaceX has that solved.
It does. It does. Now, it is not currently as fast as most people's internet connectivity on Earth. There is going to be more latency problems, but that's not always the case.
It's pretty fast now. It's surprising and getting faster.
And getting faster too. So, not only would the so you have SpaceX with a Starlink and data centers in space, and then you know who would service that for SpaceX, Nick? You know who would service it? Humanoids, Optimus,
Obviously, that's so cool.
space robots.
They could just be floating out there waiting for their next job.
Exactly. They could be up there for 100 years, not 100 years, but the decades. They wouldn't have the same problems that humans have in space. All of Elon's basically technologies could kind of come together here, and then you could have these basically humanoid astronauts servicing and repairing it, kind of like little R2D2s.
It's just so wild and weird. Like, this is so sci-fi.
Yeah, it is.
It's
It
so
is.
cool.
I mean, this is straight out of Star Wars.
Awesome.
Now, the timeline for this is an interesting question. Elon's made some timeline references, perhaps. They're an Elon timeline, though. Elon likes to get a little aggressive with timelines. So, when will space data centers be a thing? Well, in the next 5 years, it'll probably focus on a lot of proof of concepts. These are going to be launching small prototypes. Perhaps Google will get a prototype up there. SpaceX will get a prototype up there. StarCloud already has a prototype up there. So it will be probably primarily used for processing AI models. So that'll be maybe the near term, the next 5 years. Midterm, 5 to 10 years, if these prototypes are successful, we could see commercial offerings, maybe small scale orbital cloud services for targeting very specific use cases, high value AI, or perhaps government and defense work, because you can store data very securely. You can get real time surveillance data, which they would probably be interested in purchasing. And then past that, past 10 years, we could have a lot of data centers in space. If the numbers make sense, a lot of the investment and builds probably would go to data centers in space rather than land data centers.
Nuts.
Nuts. That's the only way to these technology breakthroughs like this one. We call a moonshot, and I can't think of a more appropriate term
Yeah,
to
right.
describe this as a moonshot. But things are coming together for them. Things that didn't seem possible 3, 4, 5 years ago, right before
Or
the AI boom,
practical at all. At
at
all. It's
all.
like all of a sudden kind of practical. Actually more practical than doing it on Earth.
It's quite amazing. And not only that, I continue to be impressed by Elon's long-term vision for his companies and technologies, and then how he just sticks through it. And then they seem to have an integrated vision of the future. Like there's not a lot of entrepreneurs or large companies that really think like that. Most publicly traded companies or companies
Like a
out there are
quarter at a
thinking
time.
quarter at a time. And
Yeah.
they make acquisitions not from a product strategy or future vision, but they make acquisitions for financial reasons. Look at
Yeah.
Oracle's acquisitions, look at Salesforce acquisitions. It's just to beat the numbers for next quarter to provide shareholder value. Where Elon's thing is he wants to change civilization in the world, and he's thinking 10, 20, 30, 50 years ahead, 100 years ahead. We need to get to Mars. And it's quite remarkable what you're able to do with that long-term mindset.
It's funny what Peter Thiel says about Elon Musk, where, early on early days when he's talking about starting a rocket company and an electric car company, they thought he was so dumb. And Peter Thiel now has this new respect for Elon Musk, everyone does, where he says instead of a business and growing into a vision, Elon has this ability to find a huge vision and just find a way to make it commercially viable, which is so backwards, but he's able to do it. And it's unreal. Unreal.
It really is. And not only is it important for our society and the benefits we get from it, it is important to the other companies that compete. Just look at what Google has been able to accomplish now. Google, for a long time was just reliant upon making money as a search engine and had a bunch of side projects that went absolutely nowhere. It seemed like they employed, I don't know, 50,000, 60,000 employees as some of the smartest people on earth to basically hang out at the campus, play volleyball, and eat 5 times a day. And then now that they've been challenged more from the AI race, whether it be from OpenAI, from X, through a lot of other points, they're taking more risks and their projects are landing.
And I think they're taking things more seriously too.
Yes, because their future is not guaranteed.
Yeah, really, which is cool to see.
Yes,
people that want to build, they like that. They like working hard and working with others that are working hard. It's cool to see that.
it is. Now, there are going to be other challenges with data centers in space that we didn't get into, other than the engineering challenges, other than the cost challenges. There's going to be regulatory challenges with data centers in space. If you have real-time surveillance of everywhere on Earth, that's going to create a potential lot of privacy concerns, not only individual privacy, but potential geopolitical conflicts, because you could spy on other nations in real time.
Well, wait, these data centers are, I mean, they're not building camera. That's not the plan right now. They're not building imaging systems into these today. But if they start doing that, yeah, okay, I could see that being a concern.
They would use satellites for imagery, which we already have today. We already
Yep.
have satellite imagery for surveillance. It's not real time, but we do have satellite imagery that defense contractors do buy, and it is
Yep.
a bit of a controversial topic. But this would be real time and very powerful. So there would have to be probably some international agreements for data centers in space. There would be some privacy concerns with data centers in space. There would be some environmental concerns, even though this is outside the Earth's environment, there would be environmental concerns as well.
Actually, environmental concerns, if they really start shooting these things up into space, rocket launches are loud and they're a little bit disturbing. And so people around where we're launching these rockets might have some concerns.
It's going to be a huge engineering feat. It's going to
Yeah.
be very expensive. It is a gamble, and there's no guarantee it's going to work. This could totally fail and become too costly or too inefficient compared to land-based data centers, because right now it's still theoretical.
Yeah.
But theoretically, looking pretty good. I want to be chatting with extraterrestrials via a space-based data center. I want to be,
Who doesn't?
Snapchatting aliens.
Yeah. Yeah. Every day I wake up, that's my dream.
Isn't it? Isn't it? So that could be the future. We're here to inform you week by week what the future is going to look like, because as our listeners know, we can see into the future.
You're welcome.
We were both born underwater. And when you're born underwater, like an incog, you have a vision into the future. It was actually a hot tub we were both born into. It was the 80s. Our mothers were partying in a hot tub during a storm. During a storm. And as we know, storms, just like in Back to the Future, provide ability to do time travel. We were born underwater into a hot tub,
Yep.
which also has time travel principles such as hot
That's how
tub
it
time
works.
machine.
I don't know if you know
And
that.
we can just basically see into it. And we can see data centers in space, communication with extraterrestrials. It's going to happen. It's going to be our future. Thanks, everyone, for listening. This is a fun one. We'll continue to report on the mind-blowing tech of the future. Give us a like. Give us a subscribe. Make a comment, ask a question. We will reply.
Thanks for listening. See you next week.
See you next week.